Okay, so the next step is going to be to cover vertical asymptotes. Now, vertical asymptotes are very much like removable discontinuities because of the fact that it makes us look for errors. If we look at the vocabulary page, we have the words vertical asymptote right here. And whenever I'm looking for a vertical asymptote, I am expecting an equation. I'm going to go ahead and get this one in a different color, so that way I can color code this thing properly. But now, we have the definition. It says a line that the function approaches as the y values approach infinity. So this one is basically where the dog runs along the fence. An example would look like this. It's a vertical dashed line while the rest of the function goes towards it but never crosses it. That is an example of a vertical asymptote. Now, the way that we find the vertical asymptote is we find it by identifying a zero that is only in the denominator. So, if we go back to the problem on page 4, and we want to look for our vertical asymptote, if we even have one, let's look at our zeros in the numerator and denominator. First of all, we only care if it appears in the denominator. Is there one that appears in only the denominator? What number? Are there any zeros that appear only in the denominator? Yes, this one right here, 0. And so what that means is that we have a vertical asymptote with the equation x equals 0. And now, that leads us to the next one. On this problem right here, are there any zeros that appear in only the denominator? If you got -2, you got it right. And that right there will be the number for our vertical asymptote. It will be x equals -2. To make a little note for ourselves on the definitions page, the equation will be x equals that number. Whatever the zero is that appears in only the denominator. Now, while we're at it, I'm going to go ahead and start drawing these so that way we can start sketching our graph and putting it together. We have a vertical asymptote on x equals 0. So on 0, I'm going to draw a vertical dashed line. And over here, I'm also going to draw a vertical dashed line on the number -2. -2. The graph is going to go somewhere around that. But since I didn't do it last time, let's go ahead and graph our removable discontinuities. We have one at 1, 8/3. 8 over 3 is 2.66. So a little bit more than halfway up on 2/3 at the coordinate 1, 2.66. Roughly about there. And over here, on the next one, it's 4, 1/6. So 4, 1/6 is about right there. It's an open circle. And now we're ready to get the rest of our attributes here. That is how you find vertical asymptotes.